And before we start, let me tell you your joke of the day. What is an astronaut's favorite place on the computer? And the answer is the space bar. Okay, so at the top here, we have a little bit of space. When you talk about slope, one of the things you may have been told when you were an Algebra 1 student is rise over run, which is the y values or the change in y. Again, rise 2, run 3. Notice that they're on the same line. If you wanted to, you could go down 2, left 3, and notice you'd still be on that line. Now really, you only need 2 points to graph a line. So you didn't need to get the extra points, but if you wanted to, you could. In part B, I'm going to solve this for y equals first. So I'm going to move the 4x by subtracting from both sides. 3y equals, that's negative 4x plus 12. Again, you can't add those because they're not like terms. Divide everything by 3. And what we get here is y equals negative 4/3 x, and then 12 divided by 3 is 4. Okay, so on the graph here, the y-intercept is 4. On the y-axis, go to 4 and we'll put a point. The slope is negative 4 over 3. Now the negative, I always think of that as going in the top. So negative means I'm going to go down. My rate of change is down. Down 4, right 3. Notice that I always count and graph my line, and that's it. In part C, x equals 2. Now that's one of the special cases. That would be a VUX. X equals a number is a vertical line. So x is 2. I can go to the x-axis. Here's 2. And I'm going to draw a vertical line right there. Okay, that looks a little bit better. What that means is that all your x values are 2 for every point. So for example, this is 2, 1. This is 2, 2. This is 2, negative 3. Negative 4, 3. Left 4 up 3. That's xy. 0, 1 is the y-intercept. And then 2, 0. 2, 0 is the x-intercept. And there's your line. And what we'll do is, that's the end of part 1, so we'll flip it over and do part 2.